Okay, so this is example 5 from the notes that we took on Friday or Thursday. Okay, so now on Friday or Thursday, we did a substitution. Substitution is where you take one equation and you plug it into into another equation. Like you take one equation and plug it into another one. What we're going to do now is what we're going to say is elimination. And elimination is exactly that. You eliminate a variable so you can solve one. So when you go to eliminate a variable, you're going to look at your x coefficients and you're going to look at your y coefficients. You don't care about the answer. You only care about your x's or your y's. So the question is, are your x's the same? Are they the same number? Are your y's the same number or opposites? Same. So there's two ways to do it. There's some teachers that teach you multiply one equation by -1. I just say subtract them. If they're the same sign, subtract them. A lot of teachers say, well, kids have problems with that. It's up to you. Tomorrow with your assignment, I'll post another little video up. I always like to post some videos up. So we're going to subtract them. Since the y's are the same, I'm going to subtract these two equations. Literally, that's what I'm going to do. I'm going to subtract them. Do you guys remember solving systems in Algebra 1? Okay, I guess not. So let's do this. So 6x minus 4x, 2x. -5y minus -5y. It is 0. We eliminated it. That's why it's called elimination. We're trying to eliminate one of the variables. -8 minus -12. It's going to be +4. Because -8 minus -12 minus a negative becomes a positive. And now what am I going to do? Divide by, and x equals 2. Well, that's only our first answer. Remember, when we're solving a system, we're trying to figure out where the two lines intersect. That's what we're trying to do. Where do the two lines intersect? Well, this is the x coordinate. We have to find the y coordinate. So what we're going to do is we're going to plug x into one of the equations. You guys, it literally doesn't matter. But always pick, if you're like, I don't know which equation to pick, then always pick the top equation. Okay, there's nothing wrong with that. Make yourself a system. So I'm going to plug it into the top equation. I'm going to replace x with 2. So I'm going to write 6, and instead of x, I'm going to write 2 minus 5y equals -8. Six times 2 is 12 minus 5y equals -8. Now I'm going to subtract 12 from both sides. These cancel out. They are eliminated. I'm left with -5y equals -20. Since there's not a negative sign on the outside, that's why it's -20 this time. This one, there was a subtraction sign, that's why it was 4. This one, there's not. And then I'm going to divide by -5. And my y equals 4. Now, the nice thing about systems of equations is you can test this ordered pair in the second equation to make sure it's true. You can check your answer. We know it works for the top equation. Let's make sure it works for the bottom equation. So we're just gonna check it. So we don't take the negative. We're just gonna take the 4x. So we're gonna do a real quick check here. 4 times 2 minus 5 times 4 equals -12. Does 8 minus 20 equal -12? Is that a true statement? So our answer is x comes first, y comes second, and that's our answer. So because they have one solution, that means these two lines intersect at the point 2, 4, which means they are a consistent dependent equation. Again, let me say that. You know that these two lines intersect at 2, 4, and because they have one intersection that they intersect, that means they're a consistent independent function. So from Thursday, we learned that, okay? There any questions over example 5? So we're gonna do.
Wait, do you always like subtract on the like 6x minus 5y?
No, the reason I subtracted are because the y's had the same signs. If they were different signs, let's say the -5, this was -5, this was +5, then you would have added them.
Okay.
So if they have the same sign, you subtract. They have different signs, you add.
Okay.
Did that make sense, you guys? Okay, let's try example 6. Example 6, if you have the notes, example 6 will be on the back. If you don't, we're just going to write example 6. So if you're looking at your notes, if you're looking at the notes, it gives you 4 choices. We're going to solve it, and then we're going to talk about the 4 choices. Okay. So here's the thing. If you add and subtract, or add or subtract 2 equations in a system, and the result is an equation that is never true, the system is inconsistent. So if you eliminate, you use the elimination, and you end up with like -2 is supposed to equal -7, and it's never true, it's inconsistent. If you add them together and they cancel each other completely out, then the answer is going to be dependent because they're the same line. So we're going to start. This one is going to be one of those weird ones. Okay, so are the x's the same? Are the coefficients the same? 2 and 6, they're different. Are 3 and 9 the same? No, so we can't add or subtract right away. We're going to have to multiply one of the equations by something. So I always like to change the x's. I always start with the x's this way. Can I make a 2 into a 6? Can I change a 2? Is there anything I can multiply 2 by to get 6? What can I do that by? So we're going to multiply this entire equation by 3. So I'm going to rewrite it. So 3 times 2 is 6x. 3 times 3 is, and 3 times 5 is 15. What do you notice? So I should have done this. This is my new equation, and then this is this one. I just want to show you down at home that I just rewrote it. Okay, now what do you notice? They're exactly the same. So if we so the x's are both positive, so we would subtract them, right? Well, if we subtract them, what's going to happen? If I subtract these 2 equations, what's going to happen? Yeah, we're going to get 0. So if I subtract these, I'm going to get 0 equals 0, which is true, right? That's a true statement. So that means that our answer is infinite solutions. And it means that they are dependent. Because they're the same line. So again, I just want to point out that we had to multiply because none of the coefficients were the same. We chose to eliminate the x. That's why we multiplied by 3. And then I subtracted them because the x's had the same coefficient and they were both positive, so I subtracted them. Well, it eliminated everything. It eliminated all the x's, all the y's, and we came out with a true statement. So our answer is infinite solutions, and they're dependent. It's a dependent system. Okay. Okay. Let's do this other one. Actually, I want to do one that's not on your notes. So we'll do number 7, and then we'll do one that's not on your notes, okay? Okay. Number 7, they give us 50x. I'm sorry, they did not give us 50x. They gave us 5x plus 3y equals 52. 15x plus 9y equals 54. Okay, we're going to start off just like I would start off any other problem. Are the x coordinates, I'm sorry, not the coordinates, are the x coefficients the same? So I look at it, 5 and 15, are those the same? No. Are 3 and 9 the same? No. Okay, and like I said, it doesn't matter what this is, it just matters the x and the y coordinates. So now I need to pick which one I want to change. Which variable do I want to eliminate? Do I want to eliminate the x's or do I want to eliminate the y's? You guys, it's really up to you. If I would always stick with the system unless they're the same. So I'm going to eliminate the x's. So that means I'm only focused on the x's. So I don't care about anything else. All I care about is how can I change a 5 into a 15? Multiply by 3. So in order to change the 5 into a 15, I'm going to multiply everything by 3. So my new equation is going to be in pink. 3 times 5 is 15x. 3 times 3 is 9y. And 3 times 52 is 160. Is that what you guys got? You're like, no, because I haven't even done the problem yet, Miss Fleury. And it's not 150. It is not 160 because 3 times 2 is not 10. It is 6. So this is 156. And then the bottom equation is going to stay the same. Now, in order to eliminate the x's, they're the same sign. So, am I going to subtract, am I going to add, or am I going to subtract? The 15s have the same sign, so am I going to add or just subtract? How would I eliminate them? I would subtract because they have the same sign. So I'm going to subtract these because the x's, in order to eliminate the x's, I would subtract them because they have the same sign. 15x minus 15x is 0. 9y minus 9y minus 9y. 156 minus 54. Okay. Is that a true statement or a false statement? This is false. So that means that if this is never true, there is no solution, and that this system is inconsistent.